illustrious history of McDonnell Douglas Aerospace and the Boeing Company in St. Louis. And he's answered, every question I could think of about science in the last 20 or 25 years. He's in St. Louis, and I have just pestered him to death, but God bless him. I'm one of the discussing the evidence for image formation for cloth collapse model is to, I want to influence all radiation models. I can't read my writing. To incorporate a cloth collapse mechanism, if you will, into their thinking about hypotheses. I'm hoping I can convince you of the unique qualities and how I think it encodes all the numerous features that you have to encode and account for, plus new ones that has never been discussed very much at all. And I want to also influence the all people who think about models to also incorporate neutrons into part of the radiation that's released in any radiation models. I want to explain a few more points that neutrons could calculate, could account for. Obviously, we're in a hypothetical stage, but I'd like to point those things out. And the cloth collapse hypothesis is elegantly simple, but it's and easy to understand, but to try to explain all of the 32 primary body image features, as well as the 7 or 8 secondary body image features, as well as the brilliant image and the blood marks and their features. I couldn't possibly go through that, but I'm going to try to highlight some of the more important ones in the hopefully 40 minutes that I have. The best way to understand the evidence of a cloth collapse model is to start with an excellent model where the radiation is released straight up from the body, which Dr. Rinaldo postulated back in the 1990s. It's the protonic model of image formation, and I think it too was brilliant in its use of protons and neutrons, and it was certainly a big influence on me, and it's obviously carried over to a number of speakers today. And so now, for any scientist involved, there's a series of assumptions before you get this point, and I can talk about that later. But he hypothesizes that with these assumptions, vertically collimated protons and neutrons would be released from the exterior surfaces of the body in an up and down direction. And I hope you can get the picture of how the protons and neutrons would be operating in a vertically collimated manner like this. And he has them traveling at about 1.13 MeV, and in his experiments, he worked at, I believe it was 1.3 or 1.4. So, unlike neutrons, protons aren't penetrating, and they attenuate in air, and they would stop in their travels at the most superficial fibers of the cloth, and these charged particles would then evenly release and distribute their energy on these fibers. And Dr. Rinaldo conducted his experiments at the Grenoble Nuclear Studies Center in France. The next figure here shows, like Art just showed you, a close-up of some of his results. And you can see there's not only superficiality and a straw yellow discoloration, and I'll try not to repeat all the features that Art just mentioned, but there's no cementation or added pigments. The fibers remained white on the inside, and where two fibers crossed, it was white on the underlying fiber. And according to his hypothesis, as the fibers traveled up or down, it's easier to understand understand them traveling up. They're going to attenuate and subside as they travel farther. And according to his hypothesis, the parts of the cloth that was closest to the body would receive more protons, and the parts of the cloth that was, say, a little farther away would receive an intermediary amount of protons, and the parts of the cloth farthest away would barely receive any protons, if they received any at all. And in this way, he hypothesized that you would also get a three-dimensional image. And since they're already traveling in a vertical collimation, you would get the vertical directionality to the image as well. He also gets double bonded or conjugated carbonyls. That were earlier speakers talked about that. The straw yellow color developed over time. And this method will account for many more Shroud features, but I'm just going to deal with the primary ones, if you will, in the interest of time. The primary ones really are the high resolution of the body image, the three-dimensional correlation, the three-dimensionality in which the intensity of the image is correlated with the distance that the cloth was from the body, and the vertical directionality. Now, while he envisions these in his hypothesis, it's a little bit hard for me to envision all of these things being encoded on cloth, but obviously we can't. I've never been able to come close to duplicating such a process or a mechanism. However, in my hypothesis, and perhaps Paulo, when they do some, or Dr. Baldacchini, when they're sending vertically collimated lasers up, perhaps they can devise a way. I'm sure they thought of the concept of sending it off of contoured or relief surfaces to see if maybe you can encode some of these features. But at any rate, until there's more experiments, it's hard for me to picture how you get these three main features. However, in a cloth collapse hypothesis, I think these are much more understandable. The cloth collapse hypothesis says, yep, the radiation goes straight up and the body simultaneously disappears, and it all happens in a fraction of a second. I can't tell you if it's a 100th of a second or a 50th of a second or a half a second. I don't know. But it all happens like that. And when it does, the cloth is going to fall by gravity straight down in the same configuration that it was in when it draped over the body. You'll get your vertical directionality, and it's only going to fall straight down, and it's going to fall into a field of highly absorbent charged particles or protons. Is going to only hit the ones directly below it. It's easier to envision resolution like that as well. And as it's falling downwardly in this field of radiation, and this is going to fall longer than it took for the radiation to go up, because the speed of gravity, while it's still fast, is slower than the speed of light. Even a lawyer knows that. But it will absorb, and it will pick up the number of protons in correlation to the time it was in this field of radiation. And of course, the ones that were closest to the body's going to be in that field the longest. The ones that's farthest away are going to be in the field the shortest. And of course, the ones in between will receive an intermediate amount. But it's much easier to envision the resolution, the vertical directionality, and the three-dimensionality. Well, on top of this, when the body suddenly disappears, you're going to get a vacuum. And most of the vacuum will be above the body because there's more air between the ceiling and the body than below the body and the cloth. So it's going to be a downward vacuum, and so that's going to accelerate everything I've been talking about with the gravity, and it's going to make all three properties, I think in concept anyway, will encode much better than just a straight up method. And what I want to do is try to show try to show you the benefits of how there's actually evidence on the cloth for its disappearance, and whether this was UV radiation or, say, proton radiation. Protons cause the image, of course, and the neutrons have nothing to do with the image. And I want to focus for a while on the secondary body image, and these have motion blurs and features like that I think are caused by the image, and they collectively can only be explained by a cloth collapse hypothesis. So please understand that the radiation in the original cloth collapse hypothesis that John Jackson, of course, devised and published in 1990. He first announced it in Paris in 1989. He has the radiation traveling uniformly as radiation normally does. And I have it in my hypothesis, the historically consistent hypothesis, as well. The reason is because that's one less assumption you have to put in your model. The model is designed so that the natural conditions of gravity and chemistry take over and encode these various features. But keep in mind, you could always add into the hypothesis that the radiation is traveling in a vertically collimated manner. It gets complicated. I don't think that's necessary, and I actually think a uniform direction probably encodes it as good or better, but that's getting too complicated. But after all, the most unique feature in this hypothesis is the body's sudden disappearance. Lots of hypotheses talk about protons, but the sudden disappearance is really arguably the most unique feature of all. I don't want to go into the issue either. There would not be a vacuum on the side, but I'll be happy to explain that later, but there really wouldn't. And besides, I'll quickly show up here, if you combine the features that Ronaldo has found, that Art Lin has found, and other experiments with protons have found, and then the ultraviolet light findings of various scientists, under a mechanism like this, you can account for, I have a list of 32 body image features. It's very, very similar to Giulio's and Dr. Baldacchini's, but these are expressed more in in a layman, non-scientist description, and it could account for, in theory, 32 unique features. But I want to talk about later on some even more remarkable features that this hypothesis can account for. Of course, the disappearance occurs during the image encoding process. And let me start with the first of these 7 features. They're more than just motion blurs. Some of these are image distortions that are caused by the collapse of the cloth. Let me start with the first one here. Notice on the man's upper right leg above his knee that the upper leg is about twice as thick, maybe 3 times as thick. See how it curves around and comes down that water stain? Giulio Fonti sent me an image without the water stain a couple of years ago, and I'm using that to give you a little bit better image. But see how that thick leg comes around and goes down into the water stain and down by the knees? Now look at the left leg. The left leg is about 1/3, no more than half that size. Why would a painter encode distorted fat upper leg and a thin upper leg if he wanted to be accurate? And I can just show you real quickly, this is a distortion because look on the front, the legs are the same size below the knee. And look on the back, look at the legs on the back, on the dorsal side. They're the same size. This is simply an image distortion. That's all it is. And when the upraised left leg, you got to remember the man's in rigor mortis. The leg is still in an awkward position where it's upraised like this, and the legs are still pointed down. You're going to get a tent-like effect over the left leg, and you'll start. It'll sag along the right side, and where's it going to land? On the highest flat surface, the right upper leg. And now picture a cloth collapsing into this in the same shape and form that it was in when it draped over the body, where you have a little bit of tent-like effect. It's going to exaggerate the effect, and the leg's going to look even fatter, but only on the frontal image above the knee. It doesn't occur anywhere else. And let me try to go to the next one. Okay. On the negative image, the positive image, and the 3-dimensional image, you'll see the beard is upturned, and you see gaps on the sides of the face. Now, there's other possible explanations for the gap. Don't misunderstand me. But one hypothesis is that he does have a chin band on his face. I think it's more likely that the chin band looked more like this. But it could have been on the inside, in between the hair and the cheek. But I think it's more like that. It explains a little bit more. And you got to remember, the man would be supine, laying on his back. I think that the chin band could be more under the chin and more closer to the front of the head than the middle or back of the head like that picture, but I just couldn't get a better drawing of that. But, and keep in mind, that under the cloth collapse hypothesis and with the chin band, the cloth is going to lay relatively flat over the face, and that's going to prevent a lot of distortions elsewhere. But you might get some along the nose, but look at his nose in other pictures. It's kind of thicker there in the middle, but that could be due to the fact that he just had been beaten about the head. But where you will see image distortions under the cloth collapse hypothesis is when the body disappears, that chin band is going to start disappearing. We don't know how thick it is or what it was made out of, but the cloth is trying to follow it. And when it gets to the sides, it kind of gets held up. So what you have on the look at the his left eyebrow. The image keeps going into the space on his left, the gap. There's a blood mark on the gap too, and that is consistent with chapter 11 and 12 of my hypothesis about the blood marks. And you see also on the chin, the cheek, that image goes into there. This could simply be explained under cloth collapse hypothesis where the inner frontal part of the cloth is falling and it's slowed down by the body image. And remember, his head's turned slightly to the right in rigor mortis, where they set him in the cloth. Notice on the facial image, look below the chin. And of course, the beard is upturned toward the left side of his chin. Look at the man's right side on the edge of his chin over here. There's a line going down, and in the middle, as you go toward the beard, there's two more vertical lines. There's vertical lines going down the man's neck. Well, this isn't right. People don't look like that. Picture a cloth collapsing, and a cloth had been draped over the chin. As it drapes and falls below this chin, it's going to kind of flatten and go straight down. It's going to pick up some lines. And where's it going to pick it up? On the right side, because on the left side, you've got that thicker, bulkier, higher beard, and it's not, this all happens in a fraction of a second. There's going to be not enough time to encode it as much on the left side. Obviously, I can't say this is what happened, but this is a possible explanation. Look at the awkward rectangle underneath, at the man's neck. And the cloth, as it goes down below the chin, and maybe even as it was draped, is going to kind of, you could conceivably see how it might fold under there or just land awkwardly and leave more of a horizontal impression than a refined facial image like you get. So that's a possible explanation as well. Please look over to your right of that awkward triangular thing on the neck, and you'll see like a jolt of hair, a big dot. Picture a chin band over the hair, and the hair on the man's left side of his face would be closer toward the chin. And can you picture and remember, the left side of the hair is longer, at least in the picture. Can you picture a cloth just kind of skipping down that way as it fell? That's another possible explanation, but an artist is not going to put this stuff on there. There's no reason. By the way, the first couple of these or are in John Jackson's hypothesis. And I want to get to a couple more where he predicted 20-some years ahead of time that you would find this. There's been other explanations for this, but look at the man's long fingers. Okay. I've had my wife lay on her back, and I even had my paralegal do it one time. And she's laying on a hardwood floor, a supine body. The head's going to be higher than the hands. The hands will be the second highest part on the body, but it's still going to be high. And there's going to be a little tent-like effect there. Picture this. Picture the cloth and my hands. Picture the cloth falling through Jesus' hands and disappearing into a field of radiation. The cloth's going to curve around there and keep going. Now, you can do these experiments with a cloth tape. In your mother's old-fashioned sewing basket, there's the cloth tape where you find it. And you can measure the distance on a cloth that falls like that curves around. Measure the distance on the cloth from the end of the finger back to the wrist. And it's always longer than if you measured the distance like this on the cloth where your hand was. It's a noticeable difference. And of course, this could be the bones as well running over the wrist as well as the fingers. I think the tendons is a possible explanation, but the bones and the finger bones running through there seem to be about the same size. But this too can be explained by a cloth collapsing into the hands. And the collapse again of the cloth is from its original draping conditions. And it's disappearing simultaneously with the image, with the body radiating. Okay, we just saw here that the hands and the face are the highest points on the body. In 1989, John Jackson predicted cloth collapse hypothesis was that you would find discoloration as opposed to image. You would find discoloration at the hands and the face on the outer side, this part of the cloth where the arrow is. You'd find them at the hands and the face at the highest points, because that's the part that's going to fall through the cloth the longest, and it's going to catch some protons on the back side. And Giulio Fanti does show some. I think there's a lot of debate within Italian scientists and other syndenologists as to whether there's an image on the back or not. Well, it just depends how much the back photo is studied or enhanced or whatever. But my point is, it was never going to be a three-dimensional image or a vertically collimated image or a highly resolved image anyway, but there would be discoloration there under the cloth collapse model. And I think you guys should change the debate to that, to whether there's discoloration first, and then go to the secondary question as to whether there is some type of an image there. Perhaps there'd be more of a common ground to discuss there. But the cloth collapse was the first one to predict that. How much time do I have? How much? 10. Well, we're going to speed it up. The cloth collapse hypothesis says This mechanism with protons under the historically consistent cloth collapse hypothesis says it would encode 2 full-length body images with their 32 primary features, and there's 7 secondary body image features, but also the skeletal features. We've only talked about one, but the hypothesis would also get some of the spine and some of the, if there's features on the face and head, it would also account for those. And but it would also account for the shroud's excellent condition, its pristine human blood marks, their still red coloration, and if there's coin and flower images on the shroud, if there is, the cloth collapse hypothesis would account for those as well. And I'll try to briefly cover that. And of course, since neutrons are given off, it would account for the most important dilemma or problem of all, and that is the C14 dating from 1988, because it's neutrons, and Bob has explained, neutron capture. And while Art and I have walked through the museums in Turin and looked at more linen cloths than our feet could stand, and I've looked at them at other museums in St. Louis and elsewhere, and there's linen older than the shroud, and there's medieval linen as well. I've never seen one as large as a shroud and is in excellent condition. And Kitty Little describes, 20 years ago, around there, that if neutrons, in my hypothesis, I think I said this, but I apologize. In this particular hypothesis, not only are neutrons given off, but protons. There could also be, obviously, alpha particles and deuterium, both of which act like protons. There could also be gamma rays and electrons. There could be ultraviolet light. There could even be corona discharge and other forms of electromagnetic radiation. But there would still be an abundant amount of neutrons and protons. But obviously, such an event has never been witnessed before, and we can't reproduce it, so there's no known laws. But it's conceivable that other forms of radiation can be given off. But the neutrons and the gamma rays obviously are very penetrating. They go right through the cloth, and they will ricochet around. And the neutrons, Bob Rucker calculated, will have 158 ricocheting events. They'll actually go through the cloth a couple times. And they've got more opportunities to break the bonds in the non-crystalline areas of the cloth, and that will cause the bonds to reform, and they'll actually be stronger, more resistant to bacteria and fungi, and be more flexible, and that's certainly what you see in the shroud. Gamma rays will also do this, but they're not going to bounce around as much as neutrons, but they'll go through there once. And so you've got lots of opportunities here to strengthen the cloth a little bit more. The neutrons cause that. Paulo discussed some experiments they're doing that Dr. Goldoni recommended about ultraviolet light, and as to whether that can cause the blood to be red. And he's correct that Dr. Goldoni recommended that. But that was part of a paper in which Dr. Goldoni said neutrons irradiated onto 36-hour blood on linen will cause, and then subsequently exposed to ultraviolet light or sunlight like the shroud would have received throughout the centuries and week-long exhibits and things like that over the years, that it will cause the blood marks to maintain the reddish color. And if you shined ultraviolet light on it, it would even make it a little bit redder while the ultraviolet light was on that. Neutrons can account for that, and that was the main part of his paper. He predicted that this would occur this could occur with ultraviolet light too, and I'd be interested in seeing the results. I know one scientist who's done some experiments with that, and so far unsuccessfully, but these are separate from Paulo's experiments. But so far, neutrons is the only documented instance of this. We're about done. It gets a little complicated, but when neutrons hit coins and flowers, it can cause other protons and some types of X-rays to be released and could possibly encode on linen features from a coin or flowers, or the outlines of flowers. There isn't time to go into this, but it's all in my book, and Art told me, and I wrote. But the blood marks, in part 2 of my hypothesis, there's not time to go into that. It's chapter 12 of my book. I do explain my hypothesis, and I think it's the only hypothesis that has ever attempted to explain the blood marks, which no natural mechanism has ever duplicated. But it could account for the unsmeared or unbroken edges, how and why they appear in the same shape and form in the cloth as they coagulated and formed on the body. This has never been seen before, and it works for pre-mortem and post-mortem blood, and it also would explain the serum surrounding borders, and it would explain why the blood marks are uniquely aligned, but only on the positive images. They're not aligned on the negative images. And just look at the side wound for one good example. The side wound's on the wrong side, and blood and water wouldn't have been released. So that's one other thing a forger would have to do. You'd have to code it on the wrong side for 500 years so that it landed on the right side when photography was invented 500 years later. Anyway, I'd like to encourage all models to consider a cloth collapse hypothesis and using neutrons. Part 2 of the hypothesis even gets into other things. Because the body disappears, it goes into the question of could the blood marks have done the same thing? I'm only talking about the blood marks on the outside of the body that was shed. They do wind up in the cloth. And if this is Jesus' burial garment, his appearances, the numerous appearances on Sunday morning, while he's got the wounds, he doesn't have any of the blood marks. And keep in mind, the man was bloodied from head to foot, if this is Jesus' burial shroud. So it gets into some other issues that have never been attempted by other hypotheses in discussing Jesus' appearances after the resurrection, and even some of them before. I feel like I'm trying to drink out of a water hose, but I hope you get an idea of the highlights of the cloth collapse hypothesis.